In this video, we will solve the linear programming problem using graphical method. We will take the case of unbounded solution. So the question is, we want to maximize the objective function z is equal to 3x1 plus 2x2, and we have constraints here, that is 5x1 plus x2 is greater or equal to 10, x1 plus x2 greater or equal to 6, and x plus 4x2 greater or equal to 12. And we have these non-negative constraints, that's x1 x2 greater or equal to 0. Okay, so let us see. So let us take these one by one. So first we have 5x1 plus x2. Let us remove the inequality with equality to solve this. So let us find out. So we have x1 x2. So when x1 is equal to 0, x2 will be 10. When x2 is equal to 0, x1 will be 10 upon 5, which is 2. Okay, so we have x1, when x1 is equal to 0, x2 is equal to 10. Let us say this point denotes this 10. And when x2 is equal to 0, x2 is 2. Let us say this point is 2. This is for the first line. Let's take the another line, that is x1 plus x2. x1 plus x2 is equal to 6. Again solving by same method. So we have x1 x2. When x1 is equal to 0, x2 is 6. When x2 is equal to 0, x1 is 6. So we have 0 6. So we have, let us say this is 6 here. Then when x2, if x1 is equal to 0, rather is when x2 is equal to 0, x1 is 6. When x1 is equal to 0, x2 is 6. Let us say this point. Then we have the third constraint, that is x1 plus 4x2 greater or equal, or let us remove it with the equality sign to solve this on the graph. So we have x1 x2. So when x1 is equal to 0, x2 will be equal to 12 upon 4, which is 3. And when x2 is equal to 0, x1 is equal to 12. Okay, so we have 0, rather we have when x1 is equal to 0, x2 is equal to 3. Let us say this point denotes this 3. And when x2 is equal to 0, x1 is 12. So let us say this point denotes 12. Can I join these? Let us find out. Okay, so this is 12. Now here you can see we have greater or equal to sign. So what is the common region? Rather, our common region is this time we have a problem of unboundedness. That is, this condition applies only to the maximization problem. First thing is that because of the non-negative constraint, we have the non-negative constraints. When all the constraints, in this case we have all the constraints is non-negative, that is greater or equal to some constant. Okay, so you can see, for in this case what we need to do, we need for this black line we need to shade the area above. Okay, in this line also we need to shade the above area, because we have greater or equal to. And in the red line also we need to shade the above area. So we will get an unbounded solution. So we get a problem of what we call the unboundedness. Okay, so in the unbounded we say feasible solution is unbounded. That is, these are the points in the feasible region with arbitrarily large z values of the objective function. Okay, so we will get infinite value of the z function. So in this case we will have what we call unbounded solution. So since the feasible region is unbounded, that means maximum value of z occurs at infinity. Okay, so in this case we get unbounded solution. I hope I make myself clear in this video. Thank you.